So today's topic is plastics. Today's topic is plastics. Okay. So first of all, what are the uses of plastics? Anyone? Plastics. What are the uses of plastics? Yeah, tell me. What are the uses of plastics? Okay, listen. So plastics are wide range of synthetic or semi-synthetic materials that use polymers as main ingredient. Okay, so our module name is engineering materials. In that polymers classification, yesterday we completed polymers classification. Okay, so today's topic is plastics. So plastics are wide range of synthetic or semi-synthetic materials that use polymers as main ingredient. Their plastics makes it possible for plastics to be molded, extruded, or pressed into a solid object or various shapes plastic systems. Okay. So in previous session, I missed addition chain polymerization and condensation chain polymerization differences. Let us see. So in addition chain polymerization, the monomer must have at least one multiple bond. Examples, ethylene. Ethylene, what is the diagram? It means two carbons. Okay. So in means two, I mean double bond is present in the compound. Another one is acetylene. So in addition chain polymerization must have the multiple bond like a double bond or triple bond. Okay. And condensation step polymerization, the monomer functional like glycol and nitro. Okay, so two identical different functional groups different functional groups. Okay, on to give a polymer and no other byproduct is formed in addition polymerization or addition polymerization or chain polymerization. In this polymerization, there is no byproducts are released from the monomers to give a polymer and byproducts such as water, CH3OH, methanol are formed. Okay, in step polymerization, some byproducts are released. Those are water and methanol. And next, number of monomeric units decrease steadily throughout the reaction. Monomers disappear at early stage of reaction. So here you can observe chain polymerization. So the number of monomeric units decreases steadily throughout the reaction because the monomers are converted into polymer. That's why the monomers are decreased steadily throughout the reaction. So step by step, the monomers are decreased in the chain polymerization, and monomers disappear at early stage of the reaction. At the starting stage, the monomers are disappear because it's starting only. It converts the polymer. Molecular weight of the polymer is an integral multiple of molecular weight of monomer. Molecular weight of the polymer need not to be integral multiple of monomer. So in chain polymerization, it should maintain the integral multiple of a molecular weight. So step by step, the molecular weight is increased. Okay. So in there is no need. Okay, in condensation step polymerization, in condensation or step polymerization, it doesn't maintain the molecular weight. Step by step increases. High molecular weight polymer is formed at once. Molecular weight of polymer rises steadily throughout the reaction. So here in chain polymerization, the molecular weight increases at one time. But in step polymerization, the molecular weight increases step by step. It increases. Longer reaction times give higher yield, but have a little effect on a molecular weight. Longer reaction times are essential to obtain high molecular weight. So if the addition or chain polymerization contain, it takes more time. So it contains more time. So it is effect on molecular weight. Okay. So by chance, it get less the molecular weight. That's why it maintains perfect. Longer reaction times are essential obtain high molecular weight. Okay. So in condensation polymerization, it is needed. Okay, to maintain longer reaction. But in addition or chain polymerization, it does not needed. Okay. Thermoplastics are produced. Example, polyethylene. PVC means polyvinyl chloride. Okay, and thermosetting plastics are produced by bakelite, urea, formaldehyde. Okay, and next, homo chain polymer is obtained, and condensation step heterochain polymer is obtained. Homo means the same type of monomers are present in the polymers. Okay, and heterochain polymer, different types of. Yes, Sai Chandu, tell me what is your doubt?
Nothing, man, nothing.
Okay, so heterochain polymer is obtained. And next topic is plastics. Okay, so the plastics are wide range of synthetic or semi-synthetic materials that use polymers as a main ingredient. Okay, so the word plastic is derived from Greek, in which plastics means moldable. These uh, these are high molecular weight organic materials, polymers which can be molded into hard, tough, and utility articles by the application of heat and pressure are called plastics. Example, all the thermoplastics are plastics. All the thermoplastics are plastics, is it right? So examples, PE means, what is the full form of PE? Anyone? PE full form, polyethylene. PS full form, 241. What is the full form of PS? Polystyrene. PP, polypropylene. Okay, and nylon and polyesters. Examples for plastics. Okay, so resins. So resins are the basic binding materials which from a major part of the plastics major part of the plastics, and which actually undergoes polymerization and condensation reactions during their preparation. However, the terms resin and plastics are nowadays considered as synonymous, but plastics and the resins are completely different. Okay, so plastic resins. So first, see, plastic resins are created by heating hydrocarbons. Okay, how we get resins? By heating the hydrocarbons, then we can get the resins. Okay, so in a process known as the cracking process, by preparation or by preparing resins, that process is called cracking process. Okay, so the goal is to break down the large molecules into ethylene or polypropylene, which come from the crude oil refining process. Okay. So are plastic and resins are same? Are plastic made from resins? Yes. So plastic is made from resins only. Okay. So the main base of all the plastics plastic resin. However, through different processes, these resins are transformed to fit specific needs. First, they go through cracking process. This is where the resins are created with high heat that breaks down and cracks the hydrocarbons. Okay. So what is the difference between the resin and plastic? The resin is simply a form of unprocessed plastic. Okay, resin is a unprocessed plastic, while plastic is the final product using further. Okay, so resin is the unprocessed plastic and plastic is the final product of the plastic. Okay, plastic is more stable and containing fewer impurities as compared to resins that are full of many impurities. The resin is mainly derived from plants, whereas plastic is derived from petrochemicals. Okay, so resins are obtained from plants. Naturally, it is obtained, but plastics are it is a fully contains with impurities like petrochemicals and hydrocarbons. Okay, and next topic is hydrocarbons. Sorry, thermoplastics. Thermoplastics can be softened on heating and hardened on cooling. They are generally soluble in organic solvents. Example, polyethylene, polyvinyl chloride. Thermoplastics are prepared by addition of polymerization. They are straight chain. They are straight chain or slightly branched polymers, and various chains are held together by weak van der Waals forces of attraction. Okay, already you know the characteristics of thermoplastics. Okay, so anyone say what are the characteristics of thermoplastics? Thermoplastics. So thermoplastics are can be softened on heating, which we can easily mold it, by heating. That plastics are called thermoplastics. That plastics are called thermoplastics. Okay, which we cannot remold it again. That is called thermosetting plastics. Okay, so thermoplastic is prepared by addition polymerization. They are straight chain or slightly branched polymers, and various chains are held together by weak van der Waals forces of attraction. And next one is thermosetting resins or thermosets. Thermosetting plastics are prepared by condensation of polymerization. Various polymer chains are held together by strong covalent bond. In thermoplastics, the bonds are weak van der Waals forces of attraction present. In thermosetting, covalent bonds are present. That's why thermosetting plastics are highly stable. Okay, so thermosetting plastics get hardened on thermosetting plastics get hardened on heating, and once hardened, they cannot be softened again. They are almost insoluble in organic solvents. Okay, so already you know the characteristics which we cannot remold it. That plastics are called thermosetting plastics. Examples: bakelite and polyester. Okay, Teflon, melamine, also examples in the thermosetting. Thermosetting, another name is thermosets. Okay, so classification of polymers. Polymers are divided into two types. One is fibers and elastomer. Three types of fibers: plastics and elastomers. Okay. So today's topic is plastics. That's why plastic is again divided into thermoplastics and thermosetting plastics. Okay. Thermoplastics, which we can easily remolded at 100 degree, 100 times of can also recycled. So thermosetting plastics, which we cannot remolded, that plastics are called thermosetting plastics. Okay. So examples, thermosetting plastics, all electrical gadgets. Okay. Thermoplastics, this is the diagram. So strong bond link monomers into polymer chains. This green color appears as strong bonds. Okay. So thermosetting plastics. So strong cross-link bond and monomers. So here thermoplastics contains weak van der Waals forces. In thermosetting plastics contains covalent bonds are present. That's why thermosetting plastics are very strong. Okay. So strong bonds link monomers into polymers, monomers into polymers, but weak attractive force between the monomers. So monomers between the forces are very weak. This force is called weak van der Waals force. In a thermoplastic, longer polymer molecules are joined to one another by weak bonds that easily break appear when the plastic is heated and quickly reform again as it cools. Okay. Thermosetting plastics have strong cross-link binding the polymer chains. The, the plastics are soft at low temperatures and then permanently set by the application of heat. So this is the difference, main difference, thermoplastic and thermosetting, which we can remolded, which we cannot remolded. And thermoplastics contains weak van der Waals forces are present, and thermosetting plastics contains covalent bonds are present. And again differences, see difference between the thermoplastic and the thermosetting plastic. Okay. So thermoplastics are usually formed by the addition of polymerization. Thermosetting plastics are often formed by the condensation polymerization. So in thermoplastics contains addition polymerization. In thermosetting plastic contains condensation polymerization. Okay. So it contains long chain linear polymers and held together by weak van der Waals forces. It contains a 3D network structure constructed with strong covalent bonds. Okay, already you know. So thermoplastics contains weak van der Waals forces are present. In thermostatic, it contains a 3D network structure and is constructed with a strong covalent bonds. So usually becomes soften on heating and stiffen on cooling. It does not become soften on heating. So usually thermoplastics are, if you heat the thermoplastic, it is easily softened. After cooling it easily harden. It does not become soft on heating. So they are expensive and they are very cheap. So thermoplastics are very expensive and thermosetting plastics are very cheap. Thermoplastics is soluble in organic solvents. Thermosetting plastics insoluble in organic solvents. Okay, you know the meaning of soluble and insoluble. Soluble means completely dissolved. You know, insoluble means it does not dissolve in the organic solvents. So thermoplastics are dissolved into the organic solvents. Thermosetting plastics are not dissolved into the organic solvents. Okay, so they are usually soft, weak, and less brittle in nature. They are usually hard, strong, and more brittle in nature. So, thermoplastic generally it is a very soft and it contains less brittle nature. And thermosetting plastics contains it is very hard and it is very strong and it has more brittle nature. Can be remolded. Thermoplastics can be remolded. Thermosetting plastics cannot be remolded. For example of thermoplastics are polythene and thermosetting plastics examples is plastic and plastic is a bakelite, melamine and Teflon. These are the examples for thermosetting plastic. And next one is compounding of plastics. So while preparing plastics, we have to add some resins, compounding plastics, and binders, fillers, stabilizers. These type of compounds we have to add to make the plastic. So that one we have to know. So compounding of plastics. Compounding of plastic may be defined as the mixing of different materials like plasticizers, fillers, stabilizers, etc. to the resins, thermoplastic or thermosetting plastic. Okay, to increase their useful properties like strength, toughness, etc. The main ingredients used in compounding of plastics are resins and binders. Okay, compounding of plastics, so it is a mixing of different materials. Okay, so those are plasticizers, fillers, stabilizers. Okay, so these we can prepare by using thermoplastic and thermosetting. So it increase the strength and toughness. The main ingredients used in the compounding plastics are resins or binders. First one is resins are binders. Already you saw this is resin. This is a resin. So these resins are obtained from naturally. Okay. So resins are obtained from natural product. Okay. So they are basic binding materials and held different constituent together. They are major portion of a plastics. Example, thermoplastic resins and thermosetting resins. Okay. Next one is plasticizers. Next one is plasticizers. Okay. So uh, is all plastic resin? Plastic resin are the main base of plastics. Already you know, resins is the main base to prepare by using to prepare the plastics. Okay, don't forget resins are main base. Okay, to make the plastics. Okay, resins are natural products. Okay, is resin plastic safe? Is resin plastic safe? Definitely, it is a very safe. PET. What is the full form of PET? Polyethylene terephthalate. What is the full form of PET? Polyethylene terephthalate. Resin is widely used in plastic that have food contact applications from ubiquitous 2 liters soda bottles, salad dressing bottles to peanut butter jars, according to the foundational study. PET itself biologically inert if instead is dramally safe during handling and it is not hazard and inhaled. Why is uh, why is resin better than plastic? Why is resin better than plastic? So plastics are more durable than resins. Plastic also contain lesser impurities than resins and more stable. So by comparison, we can see that resin is better than plastic for environment. Okay, the safety and protection of our environment are of greater importance than our immediate wants. Okay, resin is obtained from naturally. Obviously, it is very good. Okay, plasticizers. Next topic is plasticizers. They are added to resins to increase their plasticity um, and reduce their cracking on the surface. So examples, vegetables oil, tricresol phosphate, tributyl phosphate. So tetrabutyl phosphate. These are the examples for plasticizers. Okay. So you know who is invented by plastic? Anyone? In 1907, Leo Baekeland invented Bakelite, the first fully synthetic plastic, meaning it contained no molecules found in nature. Bakeland had been searching for a synthetic substitute for shellac, a natural electric insulator to meet the needs of a rapidly electrifying United States. Okay. So, students say the answers. Resins is resin natural product or synthetic product?
Natural
Pavan?
product.
Yes. So natural product. How we get natural product means every day. Very good girl. What is the full form of PE?
Polyethylene.
Very nice. PS.
Polystyrene.
Anyone say PP? What is the full form of PP? 242.
Polypropylene.
Polypropylene. Very good girl. So, is resin main product to prepare the base, to prepare the plastic? Is it correct? Is resin main base to make the plastic? Is it correct or not? Yes, is it correct? Resin is the main base to prepare the plastic. Okay. So, and moreover, resins are natural products. There is no impurities present in the resins. And already you know very well the plastics and the thermosetting plastics. Okay. So if you have any doubts, students, and mid-exam syllabus is 2.5 units. Okay, engineering materials in biodegradable polymers, up to biodegradable polymers. Okay.